Hello. In this lecture we will discuss using Extensible Authentication Protocol with IKE version 2. With EAP as the authentication method, IKE version 2 provides flexibility in authentication. EAP supports a wide variety of authentication protocols. Some EAP methods require a backend radius server, and other can be terminated on the VPN gateway without relying on an authentication server. We need to be familiar with some terminology relating to EAP. We have the client authenticating, referred to as EAP peer. The VPN gateway as the authenticator, which might rely on backend radius server. The radius server is the authentication server. If a radius server is in use, in this case the VPN gateway passes through the authentication to an external entity. EAP makes the authentication modular and would result in flexibility in using IKE with different authentication methods. Now, in order to use EAP for authentication, the VPN gateway has to authenticate itself using certificates. This is mandated by the RFC of IKE version 2. The reason why is that the IKE gateway will get trusted to process credentials. And you don't want to send credentials to a man-in-the-middle entity. So, let's look at what happens in the case of using EAP with IKE version 2. The initiator in this case is configured to use EAP authentication. Instead of sending the authentication payload in message 3, it omits that data. The initiator sends only its ID information. The responder receives the message from the initiator with no authentication data. Also, before we forget, the initiator sends its child SA security association, which is phase 2 encryption, hashing, and authentication proposals. It also sends along with the message, the security association initiator, the traffic selector initiator / traffic selector responder proposal. When the responder gets this message, it realizes that there is no auth payload, which tells the responder that EAP is requested by the initiator. This is inferred from the fact that the auth payload is not in message 3. So, what happens is the responder or the IKE gateway needs to prove that it is indeed the entity the client is trying to reach, and not a man-in-the-middle box. That's where the public key encryption plays a part. The VPN gateway will take the responder signed octets, hash of message 2 and encrypt it with its private key. As we know, and I know we mentioned it hundreds of times, what gets encrypted by the private key gets decrypted by the public key. So, the responder runs the same operation to calculate hash responder by running the message 2 against the hash method using the authentication key responder. This will result in the calculated hash. It will then decrypt the auth value received in message 4, with the public key of the responder public certificate. If the calculated hash matches the decrypted hash, this will validate that the VPN gateway is authentic. Also, within message 4 that was sent from the responder to the initiator, the responder tells the initiator to use a certain EAP authentication method. Now that the initiator validates the identity of the VPN gateway after receiving message 4, it will send its authentication response using the EAP method specified. The responder or VPN gateway gets message 5, it will validate that the response is accurate, based on whatever EAP method is in use. This could be against a local username and password, or other methods that is not the point of our discussion currently. If the initiator provided the correct password, then message 6 will be an EAP success message, or failure if the password was incorrect. Now, message 7 gets sent by the initiator with just an auth, which is the hash of signed octets of message 5 that is encrypted with the encryption keys. The responder gets message 7, and it will verify the auth message. It will then send its traffic selector and traffic selector responder back, along with the security association selected. This is message 8. Part of message 8 is the auth, which is message 6 signed octets, meaning message 6 hash encrypted with the key encryption for responder. The reason why it is doing that is to avoid a man-in-the-middle attack as well. Finally, when the initiator gets message 8, phase 2 is established. We call this phase 2, but the way it is named in IKEv version 2 is different. Hopefully you enjoyed this lecture. We will uncover more details in the next lecture.